Hello everyone, Raj Daman here, not your typical chemist, bringing you a quick video, doing a little bit of problem solving in terms of acid-base chemistry. Let's get the ball rolling here. Whole point of this short video is to help you predict the outcome of an acid-base reaction. So given an acid, given a base, basically answering the question, where does that proton go? Now, it's an important question when you move on in organic chemistry and you're predicting mechanisms of reactions. Knowledge of acids and bases and where exactly a proton will go will help you make better decisions when proposing a mechanism. And so to help you predict the outcome of an acid-base reaction, I'm going to give you 3 key points to consider and that you can use right away in your study. And you'll notice that in my last video, and probably in the remainder of the videos I'll make in terms of chemistry, I'm always going to give you 3 points that you can take away and use immediately. First one for today, the idea that strong acids have low pKa values, and also strong acids, when they dissociate, have a stable conjugate base. And I went over these in detail in my first video. Second point for today, proton transfer reactions. They take place from the stronger acid to the stronger base. And third, to predict the outcome of an acid-base reaction, the products of such a reaction must be more stable than the reactants. And we're going to use these 3 points in a sample problem. So let's get started. Here are 2 molecules, acetylene and water, each with a pKa value. I'll ask you first, which one is the stronger acid? And then second, how are we going to apply the knowledge that we have about strong acids, conjugate bases, pKa values, and answer this question. Here's a reaction shown below. Does acetylene react with hydroxide ion as shown below? Let's start with the first point. Strong acids have low pKa values, and when strong acids dissociate, they generate a stable conjugate base. So we bring back the 2 molecules, acetylene and water, with their pKa values. Let's highlight those here. And based on the pKa values, we can easily see that water is the stronger acid. So if we took a look at the structure of each conjugate base, acetylide and hydroxide ions respectively, we know that hydroxide ion is going to be the more stable between the 2. It's not very reactive. It's not going to want a proton as much as the acetylide ion. So we can also conclude that acetylide is the stronger base. Okay, so that's easy enough. Water is the stronger acid, and based on pKa values, we know that acetylene is the weaker acid, the acetylide ion is the stronger base. How does that help us predict the direction of the acid-base reaction? So that brings us to point number 2. The proton goes from the stronger acid to the stronger base. The question was asking, does this reaction here take place? We know that acetylene is a weaker acid than water. It has the higher pKa value. Therefore, it wants to hang on to its proton. It's less likely to give that proton away. Also, hydroxide, between the 2 conjugate bases, acetylide and hydroxide, hydroxide is not strong enough to take that proton away from acetylene. Hydroxide is more stable, so it has no need to go and grab another proton. It's perfectly fine on its own. As a result, we can say that this reaction, as drawn, is not going to take place. And finally, in an acid-base reaction, another way to check or another way to predict the behavior of an acid-base reaction is to look at the products and look at the reactants. Are the products more stable than the reactants? Because a common theme in chemistry is always going towards more stability, going towards lower energy. Overall arching theme of chemistry. So let's bring back that reaction as shown here. Is this reaction producing products that are more stable than the reactants? Acetylene has a high pKa value. That means the acetylide ion is unstable. It's more reactive than hydroxide. And based on the pKa values, water is a stronger acid. It's more reactive. It wants to give up its proton, and acetylide is reactive. It really wants to get a proton. So the way the reaction is written, do we have things that are more stable on the right-hand side or on the left-hand side? Clearly, the more stable molecules are located on the left-hand side. They're not likely to react in an acid-base reaction, And that's another way of confirming that the reaction as drawn here is not going to take place. So to summarize our answers to the sample questions, the two molecules with their pKa values, water is clearly the stronger acid. And finally, does acetylene react with hydroxide as shown below? No, it doesn't. The proton must transfer from the stronger acid to the stronger base, and the way the reaction is written here, that doesn't happen. And also, the way the reaction is written here, we get products that are less stable than the reactants. Now I'm going to get you to give this a try. Based on the principles that we've discussed, I'm going to give you similar questions. Here are two molecules, hydrogen cyanide, water, each with a pKa value. Which one is the stronger acid? And then apply that knowledge. Will hydroxide react with hydrogen cyanide in this reaction shown below? So you can go ahead, take a moment, pause the video, and come up with answers for these questions. If you determine that hydrogen cyanide is the stronger acid and that hydroxide will react with hydrogen cyanide in the reaction shown below, that's excellent. Good for you. And that brings us to the end of the video. Thank you very much for watching, and I hope that helped you out. We'll see you next time.